Welcome everyone in my channel. I hope everyone is doing fine. Now we are solving Codility for programmers. It's problem solving videos. I already made videos from lesson 1 to lesson 6, like from iteration to sorting. Now we will discuss another most important data structure, stacks and queue. We will use stack and queue data structure to solve this algorithm. There are four problems. One is brackets. This is very popular for stack. And later it's space. Second, third one is nesting. Fourth one is stone wall. Like as always, before starting to solve the problem, we should read the problem statement and get some general idea what is stack and queue. This is the documentation where you will get some general idea about stack and queue and what sort of built-in method we are using for stack and what sort of built-in method we are using for queue data structure. Those are data structure and this is the documentation. I hope everyone, before solving the problem, everyone can read this documentation, then you will get some idea how it works. For an example, I'm explaining what is this because at first we should understand the logic. When we will understand the logical part, then we can solve it in algorithm way. So this is the stack data structure. And what is stack? It's written here. Stack means you will keep one element over another one. For an example, you see here 7 is up, 7 is down to the 4, 4 is down to the 8. Same as like new element is added, it will come first. That means LIFO and FIFO data structure, not sorry, data structure. LIFO last in first out, which one will come last, it will go first. So stack is following which one will come last, it will go first. And for queue it's vice versa. For an example, 6 was added last and it's came at first. When we will take the element at first, we should take 6, but it's came last, but we should take it first. This is the main logic about stack data structure. As you can see, when at first when we are pushing, push means it's built-in method in a stack data structure. When we push 6, it's come first. When we pop, it's also built-in function, then 6 is demolished. As the same way pop, it's going. Push 3, it's coming first. Pop 3 is demolished. This is the main thing how this data structure is working. Now we will go in more algorithmic way, and to understand in more better way, we can go to the word file and draw something. For an example, this is the basket. I'm not good at drawing, and you want to keep dishes inside the basket. First one, you put one dish here, you put second dish here, later third dish. See which one I draw last, this one. So when I will, there one was the first element, then push. Push then this element. After that, when I will pop, then this element will be coming out. Because you see, when we are keeping any dishes one by one, at first we should take first one, but we are keeping these dishes last, so that's why we can say it's last in first out, like a FIFO. Just remember it, then I hope it will be more understandable. Which one will come last, it will go first. It's for a stack. It's for a stack. So now let's go to solve the problem. Now let's go to solve the problem. I already solved it. I will explain it, then you will understand what is going on. That's why I am taking my code. This is the problem statement. Just a second. Don't worry, for your understanding I will make it bigger. Let's start to read the problem statement. A string S contents of an integer is considered to be properly nested if any of the following condition is true. That means one string value will be given. This is the variable, string variable, and S is empty. That means there is no brackets in front and later. Each has the form like a first bracket, after that u, after that closing bracket, starting closing, starting closing. Then it can be nested string, otherwise it's not. Each has the form bw, where b and w are properly nested string. For example, the string, you see, it's start from second bracket and it's ending second bracket. Later it's third bracket, it's ending third bracket. Later it's first bracket, it's ending first bracket, first bracket, first bracket. That means it's properly nested part. Here, as we can see the second example, it's started from first bracket. You see, it's come at first, it should be closed here, but it's closed here, so it's not properly nested. If anyone will come first, it will go last. If anyone will come last, it will go first, because we are using a struct. So what we did in our code, we should check. At first we define a struct data structure to make this operation. After that we use for loop. Inside the for loop I define string value, and for string we should define like this way, s dot length, after that bracket. But for integer we normally use s dot length. That's it. Later we are checking condition using if statement. It's called control flow statement. So we are checking if s dot character add. This is the built-in function. We can get it through string. When we will call any string value, then we can get this built-in function. And if you will solve this problem in IntelliJ IDE, it will give you hints which method you want to use. So it's a built-in method or built-in method, you can say. So we are checking s dot character add, and we already defined the value inside this I. So I equal to this one, or first bracket I equal to second bracket or I equal to third bracket, then stack push. We already saw why we should use push method. Then it will add this value inside our stack data structure. That's why we are using push. And this value, which value will be here, it will come here. After that, if this way, then okay, then it will be push. Else if stack is empty, if the value will be empty, there is no element, then it should be returned 0. According to our problem statement, you see, if S is properly nested, return 1. If S is properly nested, that means if there is some value, then it will return 1, but proper way. If the element will be proper way, then it will be return -1, otherwise it will return 0. So else if stack is empty, then it will be like this. After that, otherwise, if character I equal to first closing bracket and stack pop means we will take it out, equal is not equal to, this means is not equal to this, then return 0. Same operation here, 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 same operation, but the below the character is changed. I hope you understand. And later we are checking if stack is empty, then return 1, else return 0. Don't be confused about this thing, because it will check our function, is there any value and is it nested. If yes, then return 1. If not, it will return 0. Let's try to run this code and we will check is it working or not. I hope everyone understand. And please write your comment, and if I should improve something else, just let me know, then I will try to improve this site. And I received some comments. I want to say thank you all of them. They suggest me something to, for an example, like audio and font size. That's why in this video I understand what sort of things I should improve. And they also asked me to describe logical side more descriptive way. Today I think I did it, but if you need more description, please let me know, then I will understand what I have to do more. So thank you very much. At first, now let's go to run this code. What is the problem? Solution, yeah, solution. If I am not mistaken, I think I understand what is the problem. I should start it newly away, then it will work properly. Leave this, start. Now I think it will work properly. Now run. Yeah, I understand what is the problem. It will work. Yeah, now it works fine. According to the all condition, it works fine. Now let's go to submit. It's evaluating. Yeah, that's fine. That means we fulfill all the condition. That's why we received 100% score. Yeah, that's fine. So I hope everyone understand. But please ask question and help me to improve some logical part or whatever you want to understand. Just write me in comment and share my channel with your friends and subscribe my channel and try to help to improve this channel. Okay, thank you very much. Take care. See you. Bye.